Okay. We have the equivalence principle, which in the book acknowledge it, but it seems kind of loosey-goosey in its language. Um, I assume it's experiments in a sufficiently small, freely falling laboratory over a sufficiently short time give the results that are indistinguishable from those of the same experience in an inertial frame in empty space. And so I assume that's kind of a practical thing. Like it's saying the experience we do here on Earth, as long as they're short enough, are basically the same as an inertial frame. But yeah, that one felt a little bit weird.
Oh, I think they're talking about when they say what they say freely falling, right? Oh,
Oh, well, the way that they
I
use
was thinking.
freely falling in this context is weird. I might be wrong.
Yeah, I guess I'm not sure what exactly what freely falling is. They were talking about the space shuttle, weren't they? Like in orbit around the Earth.
Oh, maybe it's that.
I think it's that.
So I was thinking of the whole like um I forget what video. Maybe it was the Veritasium video where the guy falling out of the building is an inertial observer, and so I
Yeah.
but I would say in regular language that he's free falling, and so that's where I was getting confused, I guess.
They mentioned that in here at the start of section 6.2 as well, I think. And I remember seeing that in the Veritasium video. Yeah, there was Einstein, right? And he's looking out the window at the guy painting the house or something, and he sees the guy painting the house fall.
Yeah. So
Isn't
I
that cool that
yeah.
such a simple thought like that could be the happiest thought of his life? That's pretty cool.
It involves someone falling off a building, but yeah.
Bit sadistic.
Yeah. Thought with the trains that Einstein had is much happier. Okay, they do say a couple paragraphs after the start of the section. The modern version of Einstein's observer falling from the roof might be astronauts freely falling around the Earth in the space shuttle. But I thought that was just an inertial observer.
Yeah, I guess that you could call it, you could call those astronauts inertial observers, I guess, right? In their frame and this frame of the space shuttle.
Yeah, although then I don't get what the equivalence principle. I really don't know what the equivalence principle is saying then. Like, what's a freely falling thing then?
Hmm.
24 apathy. Thank you for the follow.
Well, they did say if you're in orbit around a planet, you are in free fall, right? Like continually in free fall.
You're right. Yeah.
So maybe I guess that counts if you're in orbit. And then
Or
on the next
hmm,
page, example 6.3, they were talking about the space shuttle orbiting the Earth with the two ping pong balls.
yeah.
I didn't quite follow the math in that example.
The math.
It's yeah, some of the math, it's funny. I went into this feeling like, oh, I got a good math background. I'll be confident in this, but it's all the math stuff that's killing me. I feel like I understand the conceptual stuff a little bit, enough to work it out, but the math stuff kind of kills me.
I think I'm getting killed on both fronts.
Oh,
um,
yeah, equation 615. I don't know about you, but I didn't very carefully try and like verify all this.
I remember feeling I understood it at the time. I haven't. I probably read it last week though. Let me read it again. Delta S over S. This is saying it's all Taylor expansion.
Yeah, it looks like it. Yeah.
Hey, Geary.
So we're thinking of, okay, so we're thinking of 1 over r plus s squared. So if we factor out an r, we get 1 plus s over r squared, right?
Oh yeah, it's that
We get r
approximation, I
squared.
guess.
Yeah, they're doing that. Okay, I think I get that.
And then the delta S being about 1/2 a relative delta t squared is just 1/2 a t squared, like regular
Yeah,
kinematics, I guess. And I guess from there it's just substitution. It seems like.
yeah.
Yeah, I don't know. I would have a very hard time identifying. Like, if I was trying to do this from scratch, I'd have a very hard time figuring out like what do we want, or like how do we get the result that we actually want.
In a time delta t. Okay, so time delta t, and then one of the distance between the balls is going to be changed by delta s.
Yeah.
Okay.
Um. Hey,
What
Cold
about
game for
figure
the clever go
figure?
live. Oh yeah. Oh, go on.
What about figure 611?
The little snake looking thing. Yeah.
Now, I didn't follow. I didn't actually understand. Unfortunately, where did they get the equations for the coordinates of point P? They've got two linear equations there, and I didn't really understand how they came up with those. I thought, oh, this should be easy.
Um. Where did these come from?
And it looks from that diagram like satellite A and satellite B are moving with the same velocity.
Yeah. We know it's a 45-degree angle. I mean, but I'm thinking about this like with a Euclidean like equation for a line, but that's probably not it.
Yeah, I might have been. I might have been. I think I was trying the same thing. Maybe we got to go back to the metric for flat space time, right?
That might be it.
ds squared. So it should be ds squared is dx squared minus dt squared.
I really am mega. Hey, Cosmolano.
Those equations seem strange, right? Like for the CT equation, they've taken the sum of the times with the difference of the positions. And for the x equation, they've taken the difference in the times and the sum of the positions when they're sort of calculating averages or whatever.
That is annoyingly not as easy as I thought it was.
We
um,
should probably try and work out where that came from.
I agree. Oh, it's the Big Lebowski. Okay, I was trying to figure out what it was reference to. Uh, surely, like, if they're null separated because these are traveling along 45-degree lines, that should make the space-time distance.
Oh,
That
there you
should
go. That's a
inform how
good
we get
thought.
the space-time distance, right?
Oh, that's a great thought. So, oh, I see. So you're saying when we do the metric, we'll get zero. We should get a metric of a
Yes.
distance or whatever of zero between point A and point P, and also point B and point P.
Yeah, I guess like c dt squared should equal dx squared. Uh, yeah, no, at the same time, it does look like they're just doing something geometric, worth taking the average or something. I don't. I can get a bit bigger, yeah. Also received simultaneously at P. Cosmo, the question is basically where do this is talking about GPS systems in just like a simple case looking at only one dimension. Point
We
P
don't
is
really
like the
have
receiver.
yeah, we're kind of creating our own problem here. We're trying to work out how did they come up with these two equations on the screen here for CTP and XP, given that picture.
And it's a little bit faded.
In particular, like why are the negative signs where they are?
I should use the other edition of the book because it's a bit more clear.
Oh, you found another PDF of it, huh?
Yeah, this one that Dr. Cook sent us a while back. It's the international version.
Yeah, this is a little nicer.
Yeah, this is where I haven't quite trusted it because that this had the one figure that was like slightly off and gave a weird fraction.
Oh yeah, yeah, that's right.
The text is also a lot clearer, so it might be better to use for the stream.
Yeah, it looks a lot more legible over here. They also talked in the previous figure about the kid, he's on his phone and he's receiving signals from two satellites and talking about how the signals are coming out in spheres, right? So you can work out the distance. You kind of work out where you are as the intersection of two spheres there. So I guess he knows now in that picture, he knows he's on the intersection of those two spheres. He doesn't know exactly where he is. So there's some circle there that where his phone is in three
Mm-hmm.
dimensions.
Oh, yeah, it's nice. They actually
So
like lined up the actual phone right on the intersection there.
yeah.
So that's a subtle thing. Yeah, like I feel like I understand this conceptually, but for some reason this thing here I'm just not quite sure of.
Well, we could move on if you want.
Um, I guess so. I feel like this shouldn't be that hard. I'm just it's just not coming to me right now. Yeah, maybe I'll just move on.
Those equations, though, they are just coming from special relativity, aren't they?
I think they made an
Or am I wrong about
assumption
that?
at some point that made it just special relativity.
Yeah, because if there was any gravity involved, they were saying later that the actual world lines of light rays aren't at 45 degrees, right? Like if there's something else there, if there's any gravitation there, it bends them, right?
Oh yeah,
So
that's
I
true.
guess so I guess if they're going at 45 degrees, where it's really just a special relativity problem.
There are 45 degrees locally, Cosmolana says. What's DSP squared? I mean, something involving the change in time squared minus the change in x squared. But there's two different, like it says 3 points in total here. That's where I'm getting confused. I don't know. I
Yeah, we probably should be able to somehow set up two equations with two unknowns and solve the equations and get those answers.
yeah, just a
Is
wave
it just a case
equation.
like is it just a case of squaring? Hmm.
Uh, well, let's I'm reading your chats. I'm not sure. I I'm not sure. I guess.
Yeah, I'm trying to interpret it too. God. X equals C delta T plus delta X. X equals C delta T plus delta X.
Like if this was Euclidean, like we wouldn't need the second term. We would have just the average. Like the time equation would just be the average of the two times. And likewise with the x, like we would just have the average of the two x's. I wonder if is this two Lorentz transforms subtracted from each other or something?
Yeah, probably.
This buzz saying statement there two ones per degrees is expressed by CTP minus CTA equals XP
Okay.
minus XA. Okay, yeah. Okay. I'm gonna go over to Excalibur and write out what this buzz is saying.
Okay.
CTP minus CTA. It's XP minus XA. Keo Arts, thank you for the follow.
Anybody know
Sweet.
how to find, let's see, reading group.
Sulfur CTX, CTP, and XP. Oh, I guess we're adding these two equations together to solve for CTP. XP minus X. Ho. Ho. That's okay. This does give the thing that we want. Uh,
Okay, can you hear me?
yes. It's like you have a different
Are
mic
you
now,
getting are
but
you
yeah,
getting any feedback from yourself or no?
no feedback. No.
Okay, cool, cool. I just switched over to an iPad here.
Oh, okay. Yeah, you do sound it different, but you still sound fine. Yeah, I think what Fizzbuzz said is the thing that we want. These two equations, we can add them to get TP and subtract them to get XP.
Hmm.
If we subtract. Oh, welcome in, Keo Arts. Similar thing related to math in high school was studying stereometry or trig. Well, hey, that's still welcome here. I often do stuff that's complicated and difficult, but I never mind doing stuff that's like simpler. There's a whole niche of math streamers who all love to help answer people's questions too, no matter how simple.
Oh, this is cool. The Discord on my laptop's telling me my voice is disconnected because I connected to another location.
Oh,
What?
funny.
Oops.
Um,
We got Super Sardine. Is that me?
Super sardine. It must be. Or are you able to move it
Oh, it
around?
is. It is. I'm Super Sardine now.
No, you're not just a regular sardine. You're a super sardine. XA minus XB. plus 2xp. Yeah,
Was that me
Destin, I
scribbling
should
all over the
update
screen
my
too?
list.
Sorry.
Oh, that minus sign I put there just to symbolize that I did subtraction, but it's fine.
Okay.
Rising hurdle, it was recommended to us by Dr. Cook, who's a physics professor. Hey, Doomwood.
Yeah, Cosmolano, if you got other recommendations, hit us with them.
Yeah.
For me, it's anything that's good for a noob, a relativity noob.
MTW is your favorite. I haven't heard of that one.
MTW.
Somewhat is on because the YouTube chat just got really hectic last time I streamed. And hey, good computer guy. Misner, Thorn, and Wheeler? No, I don't think I know that one still.
I've heard that name Wheeler somewhere. I don't know where.
Oh wait, this should be a plus. I was wondering where my sign mistake was. I added that to the other side. Okay, this does give us the. I forgot my 1/2, but I think this was just answered our question.
Okay, thanks, Fizzbuzz. Yep.
These two seem to check out. Hope you're doing well, computer guy. Wheeler was Feynman's advisor. Oh, okay. Good to know. Oh, Kip Thorne sounds familiar. Okay. Thank you for the recommendation. Doomad, we're working on general relativity. Talking about differential geometry. Okay, so is there anything else on these equations, or do you feel satisfied?
Very satisfied. I feel kind of dumb for asking the question now.
I mean, I couldn't answer it either, so if nothing else, we're at least equally dumb.
Well.
Yeah, this is like undergraduate college level Dumoid. All right, what else is happening in chapter 6? It was kind of funny, their little aside on flat earthers.
Yeah.
I didn't realize that apparently flat earth people think that rulers are different lengths depending on your latitude. I didn't realize that was a part of the theory.
I don't think it is in general. I mean, I'm sure there's probably, as many different theories about flat earth as there are flat earthers, but I have a feeling most of them don't have degrees in physics,
Yeah, that's fair.
Yeah. There's probably a couple flat earthers who do have PhDs in physics, I'm sure, and they've probably really thought through it. But if it comes down to that, it almost feels like, well, now you're just looking at two different ways to define some kind of a system, right? I mean, you could define the Earth to be flat and define, because they said in the text, didn't they, that the theory had been developed to quite some extent. Yeah, they say a complete theory of this is worked out, including a special field in inverted commas, that changes the lengths of rulers.
Yeah.
For consistency, it is soon found that this field must affect all lengths in the same way, so that the more northerly distances always come out shorter. So, okay, you could say, well, no, the Earth's actually flat. It's just that we live in a universe where if you go north, the rulers get shorter, right?
Mm-hmm.
But I don't think that's what most flat earthers would tell you.
Yeah, that's fair. Oh yeah, Kyo. They talk about that sort of thing a bunch, where like a sphere is technically a two-dimensional surface that exists in 3D. And yeah, flat earthers definitely still exist. Okay. So section 6.6, we got this funky static weak field metric, but it's kind of
Yeah.
cool where it incorporates this the idea they were talking about in the first part, every gravitational potential being important.
Now, did you understand where equation 620 came from? Because I didn't.
Uh, I just went with it. I definitely
Yeah.
couldn't tell you why the two was there, and I couldn't tell you why one is plus and one is minus. Like why the
Doesn't it
time
feel
component
kind of
is
like
plus.
it
Yeah,
feels kind of like what we just did? I don't know.
maybe. Yeah.
I don't think it is the same. No.
Oh, congrats, Doomwood. Yeah, I this is one where I just went with it. They didn't really try to explain where it came from, to me at least. I did think this was cool. Where like, oh hey, this looks like something that's finally actually general relativity. But then later on, they have that table, and that this metric is underneath like Newtonian geometry or something. It's like, oh okay, I guess this isn't actually general relativity yet. It was neat how they showed that this can express your regular Newtonian gravity, though. Wheeler is James Hartle's uncle-in-law. Wow.
Hmm.
Yeah, the whole thing of this still being Newtonian gravity was weird to me, or I don't think I quite understand what general relativity actually is now.
Um, did you understand where equation 621 came from? Because I didn't really
Uh,
follow that either.
that's just the definition of proper time as given in the weak field metric. Or yeah, if or assuming everything else, assuming space isn't changing, I think. Or 621 VA.
They were using that figure. They were using that figure on the previous page. Yes, figure 613.
Yeah, there's
So
no
figure
change in
613
space.
is, sorry, say that again.
There's no change in space, so in the metric, like all the last terms zero out, you only have ds squared equals minus that phi thing cdt squared. But then since proper time, you negate it. And I guess the c's canceled out. But like we're routing the delta t along a constant xa, so all the space components are just zero. I think that's all they really did there.
Yeah, they said, okay, so just above that figure right there,
Mm-hmm.
it says the coordinate separations between the two emissions at location XA are delta t and delta x equals delta y equals delta z equals 0. So, okay, that makes sense, right? So does that make sense? So in this example, they're saying, are they saying Alice and Bob aren't moving now? Let's see.
In their own frame, they're not moving.
In their own frame. Okay, sure. So yeah. And so their world lines are vertical.
Uh,
So
I think the point of this is that they're showing that same exact like sending or emission versus receiving difference. Alice and Bob are standing still, and they're only showing the gravitational or how the gravitational potential affects it. And so that's why the delta tau A is different from delta tau B, even though they have the same coordinate separation delta T, because their potentials are
yeah.
different.
Yeah, that okay. I think I understand all that theory. I still don't quite know how they got equation 621. So you're saying 621 comes from plugging in dx and dy and dz are all 0, right?
Yes.
Okay, so the whole second messy term in the static weak field metric will 0 out,
Right.
and we'll get ds squared equals, and then what else do we know here?
Um,
Yeah, where'd the 2 go?
oh, they do get rid of the 2.
Oh, the relation 1 plus x to the 1
Oh, it's
half is
approximation.
approximately
Yeah.
1 plus. They also said the proper time separation, delta tau A, between these events is from 620 and, oh, wait. Oh, no, that leads to the next page. They also said d tau squared is negative ds squared over c squared. So
that's the same definition as in chapter 4 or whatever it was.
yeah, that's something to do with proper time, right? Yeah, I got you. It's page 60, equation 412. Okay. So in some sense, that's a definition of proper time, isn't it?
Yeah.
D tau squared equals negative ds squared over c squared.
I think it's exactly a definition. I almost wonder why they don't just jump straight to delta tau squared. Like, why even bring the s in the first place? I think s is more general. But, like, they're basically the same thing. Just off by a constant.
Along your world line, the interval only has a time component, no space component, says Cosmilano. Okay, so that's because we've also called it wristwatch time, right? So I'm riding with this thing as it moves. So in my frame, I don't have any space component. Yes. Okay. All right. Well, I don't think I still 100% understand 621, but I did understand. So if 621 is kosher, then 622 is clearly kosher. And then I understood how to get 623 from those two. Again, I think a couple times they did, they were using the Taylor series for binomials or whatever.
Yeah. Um, They do a similar calculation as we've done in previous chapters with this new metric with Lagrange's equation. In fact, that's the exact same thing as Newtonian gravitation. Hey, Viv.
Yeah, what happened to the mass in equation 628? Don't we need a m?
Uh,
I wanted to see 1/2 m dx dt squared.
I didn't notice that. Where did the mass go?
In the next line, they said something about if multiplied by the mass, 628 is just the Lagrangian.
No, I think they're taking whatever is inside the integral and calling that our L function. That's all 620 is just saying this is what our L function is, and then 629 is the result of Lagrange's equation after you do the derivative stuff. So mass just never
Oh, I
entered the
see.
picture in the first place, yeah.
I think I get you. I think I get you. Man, I'm glad I got all you guys to bounce ideas off. I would not have any idea how to do any of this if it wasn't for this. Don, Don, and chat. You guys are all great.
Yeah, it's a lot easier to learn when you have someone to talk about it with. Um, hey, Avantika.
All right, so that's the chapter.
Yeah, basically got to the end there.
I got to say, it was definitely a much nicer chapter than the last one, or easier to understand for me. I felt like most of the time I sort of knew what was going on.
Yeah, chapter 5 was brutal, but chapter 6 was actually achievable. Hell yeah, Keo, thank you. All right, do you want to get into some problem solving? Lose some confidence?
Sure.
Okay.
Sure.
uh, where is it? Okay, I might regret having chosen this one, but I did choose number 1, which is about the pendulum or the rod with the rotating Earth.
Okay.
There's one more image I have. I need to zoom out. I'm gonna get all this in here. Okay, so the question, what angle does the fiber of the torsion balance described in figure 6.1 make with the direction of the local gravitational field G? So they're asking, does the fiber torsion balance? So they're asking for that angle up there, I think.
Yes.
And so the reason there is an angle at all is because of that centripetal acceleration that needs to be canceled by the fiber.
Yeah, they said that in the chapter. That I felt like that was weird. They say to be canceled by the fiber, but isn't it created by the fiber or no?
Uh, if the Earth wasn't rotating, the ball would just be right next to the pole,
Yeah.
and the fiber wouldn't have to do anything. But I guess because the Earth is rotating, uh, actually, that's kind of weird. That doesn't quite work in my head now. Hey, Cook.
Hey, Dr. Cook. So this force here is what they call a fictitious force, right? The centripetal one. Isn't it? Isn't that force there created by? So if we were standing here, like looking at this, if we were, can we at least say this? Tell me if you think this is correct. Can I say that this tension in the fiber plus the gravitational force plus this force here, do those three forces should add up to zero, shouldn't they? I mean, it's in
Yeah.
equilibrium. Okay. So we can do a force triangle at least.
Yeah, so maybe we shouldn't overthink
Just
it.
say like this tension plus. This doesn't seem right. Sorry, I'm confused. I want those three. Okay. I want those three arrows to. Oh, you know what? It's because this one's backwards, isn't it? I think this one here is. Damn it.
Oh, no.
Damn it. How do I undo it? How do
Control
I
Z.
undo it?
Or
I don't have a control Z.
in
I'm
the
on my iPad.
next to the zoom buttons, there's an undo, the little
Yeah.
arrow. You can tap that.
Let me see. Next to the zoom button.
In the lower
The
left.
zoom? Oh, I see. I see.
Yeah.
Thank you. Sorry, Tom.
No worries.
Oh God. Now I forgot what I was doing. I was saying that I think this arrow's backwards, right? Yeah, because if I put the tension there,
Oh,
then that force and that should close a triangle, I think.
I just realized why that acceleration exists. It's because the rod is following a circular path parallel to the equator. And the centripetal acceleration is pointing directly towards like the axis of the Earth, I guess.
Yeah.
Okay.
Yeah, so if you look at that figure, this pole here is at right angles to this vector here. Yeah.
Right. Yeah. I thought it was weird that they had that little pole right there, but I guess that's why they did that. To try and make that obvious, maybe.
Yeah.
Yeah, we should be able to, I mean, hopefully just in terms of theta, say some component of tension cancels gravity and some component of tension cancels acceleration.
So they told us latitude 47, right? So if we know the latitude, we should be able to find the radius of the actual circle this thing's moving on. Right?
Oh, right, yeah.
Because we know the radius of the Earth. And then we take what? Either sine or cosine 47 or whatever, and we get the radius of the circle that this thing's actually moving on. And then we can find the centripetal acceleration, right? Because what do we know? We know 24 hours for one rotation of the Earth, so we can find the velocity.
Right.
And then v squared over our radius will give us the centripetal acceleration. And What is the radius of the Earth? 6,378 kilometers. Can you hear a tapping noise when I write on the screen here?
No?
Nice.
Hey, MMD.
$47 degrees. Uh, 47. Cosine.
So you're already working on the second part of the question, right? With what you're doing there?
Am I? I don't know. I thought I was trying to work out the first part.
um, I may have done it. I was just kind of thinking like t cosine theta should equal the gravity and t sine theta should equal the centripetal. Just break it into two
Okay.
components like that. And then I divided the two equations.
Well, wait.
I guess we
don't
could get
think
rid of the
that
masses,
works,
but
does it?
uh, maybe it doesn't. I might have gotten the geometry of this wrong.
Well, because the centripetal. I'm trying to visualize in my head if I understand what you have written here. T sine theta, yeah, because the T sine theta is going to come off this way, right?
Uh,
I mean, the T sine theta is going this way, I think.
oh, did I flip sine and cosine?
I don't think so, but isn't T cosine theta comes up here to balance with your mg, but T sine theta goes this way.
Oh, I see what you're saying.
I don't think either one of those aren't playing nicely with the MIA here.
That's annoying.
This is why I think we need this 47-degree.
Okay, I was wondering why you're doing all
latitude.
that. Okay.
I think we need that to work out, like, right? Because this whole pole here is at some angle here. Well, is that 47 right there? I think.
Yeah, I was taking the MGG to be parallel to the pole, I guess.
Well, that's true. It should be.
Okay. But yeah, I guess the angles, yeah. Maybe the equation I wrote for gravity, the gravity component is true, but the centripetal acceleration one, but that still needs to be canceled. Maybe.
I think this is cool, but we just have to work out where the 47 degrees comes in. I think then we can continue with what you did down here.
Okay. So you. Okay, yeah, you're working on finding the circumference of the circle that the rod is moving in.
Yeah.
So you just found the
But we can abandon.
radius.
Well, let's shelve
See your
that for
thing there.
now.
Oh, okay.
Let's draw. I'm going to draw this here. This way. So that's the tension. This is MG, G. And this here is MI,
Chuck, thanks for the follow.
A. Now the question is, where's our 47 here? Our 47 would be
Um,
here, wouldn't it? This is the 47 degrees.
yes. Yeah.
Okay. Yeah, right
I
there,
think
right there. Okay.
technically MGG isn't quite parallel to the pole, but I think we can assume it's close enough. Like, it's a good enough approximation.
I'm just making it parallel, so
I
you
was
think
thinking
it's
like,
not quite parallel? Let's assume it's parallel.
yeah, like if it has point to the center of the Earth, so it would be a little offset from the pole, but I think it would be really subtle.
Yeah. Okay, now, where's theta in this picture I just drew? Theta is between the T and the, okay, so theta is this little one in between those, isn't it? Theta is in here,
Yeah,
I think.
I agree with that. I think I can find the angle between gravity and the centripetal acceleration.
Okay.
Wait, can I? uh, it has something to do with that 47-degree angle. I think it's also 47. It's like an alternating angle thing.
Yeah.
Yeah.
Okay, good, good.
See, I guess that
Oh yeah. So
that's
you're
like
saying
this
that
angle up
47.
here.
Yeah, oh, I got you. Okay.
I don't know. I mean, could we have just law of cosines on theta though? You know me. Well, that wouldn't. I don't know. What's
I feel like this is
no.
where we have to go back and find the and use the radius of the Earth and everything. Why does this triangle look wrong to me? I feel like I'm doing something wrong here.
I'm getting confused with the tension and the gravity pointing complete opposite ways. I know it's supposed to be like that, but I'm getting weirded out with what the angles are.
Yeah, sorry about my handwriting. Can you see can you understand what the triangle I drew? It's supposed to be a force triangle with three vectors that closes, right? So it's in equilibrium.
Mm-hmm.
I don't know if that's even does that seem right?
I've seen you do it before. I never learned the force triangle thing for myself. Should the tension be
I'm
the
just
longest
wondering if it's
side?
legit. Sorry, say it again.
Should the tension be the longest side?
That's why I'm upset because if the tension's shorter in that picture as they showed than the weight force, then how could the component of the tension balance the weight, right?
Yeah, the arrow for gravity is a lot longer, you're right. It shouldn't be though, for this to be in equilibrium.
Well, maybe the whole point is not in equilibrium, right? So the real forces are tension and weight, and then the centripetal force is a fictitious force, right? By the way, I never understood fictitious forces. I never really learned those properly.
Me neither.
But I've been told that centripetal force is a fictitious force. So in other words, it's not really there. It's just we put it there to make the math work or something,
Yeah.
or the free body diagram. So if I didn't put it there, I'd just have the weight force and the tension force, and they wouldn't balance out. And so then the resultant of those two forces would be that centripetal force. Maybe it's fine. Maybe it's fine. So let's find the velocity, right? So what's the velocity of this thing?
Uh,
Is it just 2 pi times this radius divided by 24 hours?
yeah. Now give us, I guess, kilometers per hour.
Okay.
Then A is V squared over R. So we can get the acceleration.
Okay.
4 pi squared. Actually, I do the cancellation. Oh wait, never mind. I still need 4 pi squared. The 6378 gets, it will be squared, but it gets canceled.
It got canceled, right?
Yeah. Well, the cosine should. Oh, never mind. No, wait. Oh, the cosine. You're right. That the cosine gets canceled too. I was thinking the radius of the Earth
One
was
of
our
them.
r, but it's not. It's the radius of the circular motion. So yeah, you're right to erase that squared.
And so this A is really that A right there, right?
Yes.
Okay.
Fictitious is a bad word for it, better to call them inertial forces. They appear to act on inertial observers in the coordinates of a non-inertial observer. Oh. That's cool, Cosmolano. What are we doing with this?
So now let's see. What are we trying to find again? We're trying to find the angle.
Oh, maybe the
What do you
error I
mean?
made, we need to split centripetal up into components. Like the component that is perpendicular to tension. Maybe I'm splitting the components wrong. That was a mistake in my work here.
I thought this was fine, but I thought the second I didn't agree with the second one maybe.
Uh, I guess in my work, am I taking gravity as straight down? I just need to see the free body diagram. GG, just below perpendicular MIA. Then tension will be up and to the right if I'm drawing it like this. Maybe that's where I'm getting confused, where I don't know, I feel like I was doing some of this taking gravity is down and some of this is taking tension is up. Well, you're allowed to have that opinion, Lucas, but there's a lot of it's a lot of baggage believing that would come with. Oh wait, that can't be right. Wait, is the centripetal acceleration not supposed to cancel? It is rotating around the Earth. Ariane, I don't know.
I think the way I set it up was that the MIA arrow kind of goes the other direction. In other words, I reversed the sense of that vector in my picture.
But centripetal acceleration points inward, right?
Yeah. But the centripetal acceleration is really the resultant force of the tension and the weight, I think. So it doesn't make sense to put it on this same picture as if it's another force, because it's not. Am I right about that?
Yeah, the more I think that's the MA result of the sum of the forces. What you just said.
Yeah, and you can almost see it from the picture from the book, right? If you imagine in your mind taking the t vector and sliding it right down to so its bottom is at the base of the m, is at the point of the mgg vector, it really does close a triangle there, I think.
Okay, that would make more sense. So that means MA would be T sine theta minus. Oh, I need more trig than this, don't I?
How do you move something again?
The
Hand?
number 1, like the cursor icon, right next to the hand.
Oh, I was trying to move it. I put a box around it. Oh, there we go. Yeah, there we go. Thanks.
Mm-hmm. Oh wait, I just got the same thing that I already wrote. Uh,
Yeah, I think it should be MIA is MGG. Wait. Yeah, wait. Don't you need your thetas on your MGG? So shouldn't it say T equals MGG times cos theta?
uh, I think so. I think I'm getting confused with what's on the hypotenuse here.
I think the hypotenuse is the MGG.
Yeah, at least as I drew the free body diagram down there, yeah. Or even that like theta right there.
But you know, strictly speaking, we don't even have a hypotenuse here because we don't have a right angle. I don't think that the three vectors aren't making a right angle triangle. They're making a triangle, but it's not a right angle. It's not a right triangle.
Ooh. I don't know. Ugh.
So tell me, were you convinced by the triangle I drew?
It
I mean,
seemed
did you think it
right.
was legit? Okay. I'm wondering because we know, can't we just say MI and MG are really the same thing? Wasn't that the whole purpose of this, was to understand that they're the same mass?
I assume we can do that here. Yeah.
So what if I scale everything down here by mass? Let's see. I like having bigger triangles. Yeah. So this is G, this is A, and this is T over M.
Just talking about accelerations. Okay.
So can we use law of cosines here? What do we know? The problem is we don't know a lot of these. Oh, we know A.
We need
Yeah,
to get rid of
we know A, and we
tension.
know, but we
Yeah.
don't know G, do we? Because I was about to throw in 9.8, but no, it's not, because we're supposed to be finding it. So I think we know A. We know one side and we know one angle. It's not enough.
GT is the component of G in the twisting direction. But the MGG is 9.8. GT is different from G.
Oh, wait a second. See, I had not understood what the twisting direction was. Oh, the
That's the
twisting
centripetal, I
direction.
think. Yeah, I guess. Right? Or go on.
I think the twisting direction in that picture, does it look to you like it's at right angles to the tension?
Oh yes, it is. They said that. Or it's really a twisting direction right there, and it's perpendicular.
Oh.
I should have understood that a lot sooner about this question. But yeah, I think the G in your triangle, it is 9.8, but maybe.
Is it?
I think that's just regular old gravity. Yeah.
The local gravitational field. Well, it should be close enough, right? Let's just call it 9.8.
Yeah.
Okay, then we could use law of cosines here if we wanted to find. Well, wait, we'd use law of cosines if we wanted to find the tension. Well, we can just we can use law of sines to find angle theta, right? Let's try that. So, oops. How's it
We
work
might need to
again?
get rid of the tension either way. Like, use the fact that tension and gravity have to cancel in some way, but I think either of those should work.
Okay. So law of cosines, right? Okay. I'll write it down here. So T over M squared.
The twisting direction is G sine theta. Oh yeah, I think it is. Yeah,
So that'll give us.
or do we need, like, just looking at the original thing, it's in there's a component of gravity that's being canceled by, oh wait, no, but maybe it's not a right triangle like you were saying. But let's just keep on going with your work.
So that should find us T over M, right?
Oh, okay, and then we
Okay,
can do a different law of cosines for theta. Or law of sines even.
Yeah, how about law of sines? So oh, this kind of sucks, doesn't it? This looks kind of bad.
I already have Wolfram Alpha tab open. I'm typing in your law of cosines.
Okay, yeah. Do you want to just Wolfram the hell out of all this?
Yeah.
Yeah.
Okay, so that's acceleration. We need to square it. A times G times cosine of 47 degrees. $291.5 is the T over M. No clue if that's reasonable. And then the
What
law
was
of
A?
sines. I didn't get A separately. I can. Just gotta copy paste this. A is 298.1 kilometers per hour. I guess per hour squared. I don't know if that's reasonable either.
Okay. It sounds, well, they're in the same order of magnitude, aren't they? That might be good.
291.5 divided by sine 47. Oh wait, it did do degrees, right? Good. Oh wait, I did this. I gotta divide by that, parentheses. It's A divided by, okay, and that's A. That'll be, so we need to do arcsine of this entire thing.
Okay.
48.42. That can't be right.
That's outrageous, isn't it? Is that because we're supposed to, we should be finding something very small.
Yeah.
I mean, it couldn't even be a degree, could it? And it's got to be much less than 1 degree, I would think.
Yeah.
Okay, let's just follow this work. I don't know. Our units might not be all checking out. So you said, okay, so this V was kilometers per hour, right? Yeah, so this is, so maybe that's not, we can't square V to get A, can we? If we do V squared over R, then our acceleration is kind of weird unless it's,
Oh, this is in kilometers per hour. Maybe we need meters per second? Or,
yeah, we could, or we could, yeah, that's probably better, right? Just convert it, just get it meters per second. Because if we're using 9.8 for the other one.
oh, true. Yeah, that's definitely off in that way.
Okay.
Um,
So what do you have to do? Divide by 3.6, I think. Kilometers per hour. 3,600, or multiply by 3.6.
I can make Wolfram Apple do it for me.
Okay. 1 kilometer.
82.81 meters per second. Wait. Oh, wait, no, this is supposed to be acceleration. Kilometers per hour squared. To meters per second squared. Be helpful like able from a possible task. And now it doesn't want to do it. Okay. Let's get the number. 298 kilometers per hour. That's too many digits. Okay, 0.023 meters per second squared. That's probably a reason when we go from hours to seconds. Okay, 0.023 is our acceleration.
What do we get for the velocity? Do you get the velocity? I'm getting 82.8 meters per second. Doesn't that sound, is that low?
Uh, sorry,
Maybe
what
that's
would
all
you
right.
for velocity?
82.8 meters per second.
2.8. Uh, that does sound a little slow, I guess. Well, no, it's meters per second. Unless you're still.
Yeah.
That seems fast then. Never mind.
All right.
That's a yeah. 6378 cosine 47.
What'd you get for the acceleration?
Acceleration in meters per second is 0.023 meters per second squared.
0.0?
0.023. Yeah.
I got 1.576.
That's not good.
Wait, did I forget my 2 pi? Sorry, Don. No, I didn't forget it.
I'm getting 316 meters per second. Are you in degrees or
316.
radians? Or for foot velocity, I got 316.
I'm in degrees.
Okay.
Maybe I forgot to. Let me try it. Let me try it again.
See, 378 over 24. I think I did it right. Ritwick, 1 second.
Yeah. Did you say 316?
Yeah.
Yeah. Sorry.
Okay. We agree on that. Some 316.
Wow, you square that and you get almost exactly 100,000.
Oh, funny. Yeah. We have to divide it by the radius of the Earth in meters. 6378. 1, 2, 3. Now, I'm getting 0.015. It's closer to my original 0.023, but why I trust 0.015 more, I guess. Confused why this isn't the same thing, but I'd rather go with 0.0156 as the acceleration.
I just did and got 23.
For the acceleration,
Yeah.
did you divide by the radius in meters?
Yeah.
So wait, for velocity, you got 316 meters per second, right?
Yeah.
And then you square it and divide it by 6378 with three
Oh,
zeros.
divide by 1,000. Oh, sorry. So what'd you say? 0.023?
Yeah. Or sorry, no, 0.0156.
Oh, now I'm getting what I think you had before, which is 0.023.
Oh God. Okay.
It sounds familiar. I think you said that.
Yeah, I did. That's what I originally got.
Oh, man.
The same calculation and getting different numbers.
I think 0.023 sounds good though. Maybe.
I'm just not getting that though.
Let me see. On Wolfram, did you do it?
Yeah.
And what did it give you?
So I'm 316.3 squared over 6,378,800 or 378,000, so sorry. I'm getting 0.015 like 7.
Oh, wait. You forgot the cosine 47 here.
Oh, okay. Good call. 0.023. Okay. We agree.
All right. Man, I feel like a knucklehead.
Me too.
It's like the Three Stooges do general relativity.
Computer guy, you won't clip that? Thank you. The Three Stooges might be an improvement. We just got the two Stooges here. We might need a third Stooge. Okay, what am I? Okay, so my T over M is 9.78, which I think that tracks. Should be a little less than gravity. And then I'm doing acceleration, which is 0.023.
Yeah, 9.79 for T over M.
Yeah, yeah.
It feels good.
Okay, I'm getting 0.09 of a degree.
Nice.
That's at least a reasonable number. Or basically 0.1 degree if I round it. Oh my god.
0.0. Yeah, so, okay, good.
Okay, well that's part
A
one
tenth
of
of a
number
degree.
one.
That feels good. That feels good. That feels good.
Okay. What is the value? GT. I think here we can just take. No, can't. No, maybe we can. We can do the acceleration we just found times like cosine 47? Or no, cosine of the angle we just found.
What does that little T stand for?
Sine.
Does that stand for twisting? T for twisting?
I guess so, yeah.
I forget what the superscript stands for.
The component of G in the twisting direction by GT. So I think we want G sine angle we just found. I'm getting 0.02 basically meters per second squared.
Okay, so this should be small, should it?
Yeah.
Where is that on the picture they gave us, right? So the picture that they gave us there, where does that show up?
There, I think. It,
Is it there, or is it this tiny little one here?
wait, a tiny little one there? What?
If I zoom in, so there's a triangle here.
Mm-hmm.
Is it this little segment here, which is kind of hard to see in the picture?
It's just that's floating off in space, isn't it? I don't understand what you're.
Well, okay. And so instead of putting it over there, I'd put it over here. But it's the so I'm thinking of, I guess I'm thinking of this little triangle now. And I'm thinking I want that component.
I don't. I'm just like looking
Well, that's
exactly
not, well, wait,
at their
that's
phrasing.
not in the twisting direction, right?
Yeah, I'm looking at this triangle here and getting this side of it because that's parallel to the twisting direction.
Yeah.
So I'm not thinking about the centripetal one at all.
So what you just did was you did G, you did 9.81 times the sine of that angle we just found.
Yeah.
Okay. And what did it give you?
0.02.
Which I guess is meters per second squared.
Yeah.
Okay. What do you think? Should we check it out?
Yes. So. Let me just like write this on the scale draw.
Yeah.
9.8 or GT equals 9.8 sine 0.1, which is about 0.02 meters per second squared. Okay. Solution manual.
Cross your fingers.
Oh. Oh, theta is about 0.1. G is about 0.02. I skipped straight forward to seeing what the final answer is. I didn't see how they did it, but we got the right result.
Nice. Yeah, it looks like they did not do what we did.
Theirs wasn't. It doesn't
like
seem that easy though. They got some funky trig that's happening.
Well, I like funky trig.
Yeah, this is weird because things weren't right
trig.
triangles. I was being too like liberal with that, I guess, like you were saying. I wouldn't have done it this way.
It's kind of nice. They kind of derived a equation, didn't they? Yeah. Where lambda is the latitude.
Yeah, it did.
They say it's easiest to resolve the forces and accelerations along the fiber and the perpendicular twisting direction.
The thing that you did with the triangle, I think, didn't really. I think that was a different thing.
Yeah, I think I chose a poor way to do it. I think I made it hard for us.
I feel like I understood it. I mean, I understand it more than I understand this solution, at least. I don't know. I'm just happy that we got the right result, though.
Yeah, it's always nice to get the right answer.
Um, we're about
It
to,
only took us like the whole time. It only took us like the
yeah.
whole. Oh,
About to
man.
ask, like, we can try to squeeze one more in. The next one I've chosen is a straightforward one, allegedly.
Okay.
Okay.
Yeah. If you
If you
want to,
feel
yeah,
well.
let's. Yeah, I'm happy to take a look at one.
Okay. Number 3 was about, 'cause that was also kind of like pretty mechanicsy, calculation-y. This one is about light. So I brought in down below our previous work.
Yep.
Assuming the acceleration of gravity at the surface of the Earth, how wide is the elevator? I think they say an elevator, but this is a rocket. I was confused by that when I read this, but how wide does it have to be in figure 6.5? How wide does it have to be for the light ray to fall by 1 millimeter over the course of its transit? It's a thought experiment that could be realized on the surface of the Earth. So we're just in a rocket that's accelerating with magnitude gravity,
Okay.
I guess.
Okay.
Uh, feel like there should be some sort of maybe how wide does the elevator? This feels like we use some kinematics equations, I guess. We need to figure out how long transit takes just horizontally and then apply it to the vertical motion.
So based on this picture, based on the picture you've got there on the screen. Oh, it's on my screen too. Nice. Is this here a parabola? I want to say that'd be parabolic, right?
I feel like it's basically a projectile, yeah. And would be a parabola. I, yeah, I think so, yes. I'm saying the width of the elevator is c delta t. We're not given any dimensions here, are we?
The width is c delta t. Oh, I like that. Okay.
Oh, Dr. Cook might have just given us the equation we want. Height is equal to 1/2 gravity times squared. And time is w over c. Okay. And that's what
Oh, time
the
equals
equation that I
w
just put
over
there.
c. That's what you were doing.
Yeah. So 1 millimeter is 1/2 times 9.8 times w over c squared. Just solve that for w. Okay. And our result will be, I guess, I'd rather, instead of millimeters, let's make that meters. Point. Well, Wolfram Alpha will deal with this for us. 9.8 meters per second squared times.
It's going to be a pretty wide elevator, isn't it?
Probably, yeah.
You put 9.9. Not that
I
it's a
did.
big deal, but it's not going to change it much.
Wolfram Alpha still hates me for some reason, though.
Oh.
Why it won't just do this for me? Maybe X needs meters. That there shouldn't be that many solutions. Okay, fine.
There you go.
Well, it's getting like 6 different solutions, or I guess there's only 2. I don't know why it looks so weird though. It's repeating the same one many times. I don't know what Wolfram is doing. Let me just get rid of the units. The speed of light in meters per second is 3 times 10 to the 8, I think. Does that sound right?
Yeah.
Okay. Okay. So in meters, this is 4.3 times 10 to the 6. So that's pretty dang wide.
So we just said the radius of the Earth was 6,000 kilometers ish.
Yeah, and this
isn't
this 4,000 kilometers?
Yeah.
4.2 megameters. That is a big elevator. There's the second part. Is the thought experiment can be realized on the surface of the Earth? No, this is bigger than the. It needs to be wider than the Earth, right?
It's like 2/3 of the radius of the Earth or something.
Oh yeah, you're right. The Earth is 6,000 something kilometers, and that's 4,000 something kilometers. So oh yeah, we can talk about, or maybe that's like an equivalence principle thing. There's no way the laboratory is small enough. Well, no. We're accelerating. That's the wrong thing to talk about, I think. I assume the rotation of the Earth is going to affect it for such a big distance, though. Maybe that's the better reason. Like the scale is too big. Even the curvature of the Earth, too.
Yeah.
Ricky, but check the answer, or do you have any other?
No, I
think
think
you're
that's
chewing
good.
on. Okay. G would vary over that horizontal. Why would it vary horizontally? If it's like parallel to the equator, it should be the same, right? I'm looking at the solution. The surface would curve away from a rocket. Oh, that's what you're saying. I was imagining it would follow the curvature of the Earth. But if it's just a straight line, then yeah.
Why'd they say 3,000 kilometers, but we got 4,000? I think they just rounded it, maybe.
They calculated like the vertical component first. Wait, what? Yeah, we should be able to follow back through with their calculation.
Yeah, it's not 0.01 seconds, 0.014 seconds.
Okay.
I just did it on a calculator, so I think if we use that, we'll get closer to what we got.
I get the same for that piece, and then we're multiplying that by the speed of light.
Yeah, that's what you got.
3 times 10 to the 8. Yeah, 4.28 times 10 to the 6. That's a very weird way to round it. I wonder if that's I'm gonna look in the error thing because there's no way that's how they rounded that. Where is it?
Oh, does it have errors for the solutions as well?
Yeah, that same page that you linked had a
Oh,
thing for that. Problem, we're number 6 or chapter 6. Six 6.9. No, wait, this is 6.3. I don't see it. No, there's no
I mean,
correction.
they probably don't care about the rounding.
I guess not.
Yeah.
Oh well. All right, I guess we'll probably call it there then for this Saturday.
Well, this was cool.
Yeah, we
I
did
really
2
like this
problems
iPad.
right. You like what?
I really like this iPad. I got to get used to writing on it. It seems.
Oh, good.
And this is nice. I don't have headphones on. It's much nicer without headphones on.
Oh well, so like you're listening through speakers?
Well, it's just the speakers on the iPad. Yeah.
Oh, I'm surprised there's no feedback. That's great.
Yeah. Well, I wouldn't know if there was, but I asked you and you said it. You
No,
can't
yeah,
hear it. Right?
you sound great.
Nice.
So awesome.
All right.
Well, I guess I'll see you
Thanks,
around.
Don.
Yeah.
Yep. See you next week.
Yep. Bye. All right, let's switch over to math stuff. Yeah, that's basically how these reading groups go, where we discuss content from the chapter and then solve some problems. And we're generally confused pretty much all the time. That's just part of the deal. Got to be comfortable with doing and saying stupid stuff, because that's how you learn. Yort's iPad is very comfortable writing and drawing. I believe it. I just have like a tablet that does the trick. Flip that. Yeah. Okay, so I'm gonna take a minute to switch over my title category. It's a rare day when we have a 100% success rate on solving the questions correctly. Now, we didn't bite off like the most difficult questions we could have, but even then, we don't usually get them right, so. Yeah, thanks so much everyone who piped in to help there. It's always hard to read everything super closely and acknowledge everyone's chat verbally, but it's great to have the participation, if not in voice, then through the Twitch chat or YouTube chat. Okay, I think I'm all switched over. Oops, I need to get a copy of this. Oh, what is RAL? I don't know. So that's for chapter 6 part 1. Spend 1 week on chapter 6 before moving on. Is that, why is there a line break? Is that supposed to be there? It apparently is. Okay. Noish. Take down that pin. All right. I don't think we have any questions waiting for us. If someone does have a question, feel free to to hit me with it. Night, you're good, Fembox. So maybe I'll pull a question from somewhere. From a textbook. I probably don't want to pull a general. Oh, you know what we could do? There was a chapter 5 question that I still am not even sure how to start, really, but we can try to think about it a bit more. I need to get my Excalibur. Hold on. Or not, Journal++. I have had this question from chapter 5 partially done for, I think, 2 weeks now. Mostly because I'm just too busy to think about it during these streams. But since we have a minute here, how the hell do we do this? Actually, I kind of have to use the bathroom. Maybe I'll leave the question up. I'm gonna be right back though. All right. So thank you, thank you. Does the law of cosines hold in 4-vector land? Thank you to computer guy. Because how we proved the usual formula, well, we did it in 2 ways. The usual formula people know and maybe love. You can do it with a lot of cosines. It takes a little bit of computation, but you can do it. Or I remember Jasu showed us this really quick way of doing it with polar coordinates. Yeah, that's why I don't know where to start with this. Like, does the law of cos like what is the law? Is there a law of Cauchy's? If we know their time like, does that tell it like? Can we try to prove some law here? Hmm. Uh. Okay. Maybe. Bravo's names. Yeah, sure. I can take a try with it. If you have time, I can choose a frame where spatial components of 1 are 0. Oh, like put the origin at one of the vectors? I mean, oh, just some more of those fluid physics, yeah. If we're doing A dot B, shouldn't they have the same, are we taking them as having the same point, so we could put them both at the origin? Oh wait, one of the 4 vectors. Oh. So you're saying we can have a... Yeah, since it's a time-like, that's like the ultimate time-like vector. That could be your A. I guess the squiggle thing. And that could be B. Differentiable logic cellular automata? That doesn't sound like something I'm gonna know. If you can be more specific, though, I can... I don't know, that sounds like something pretty advanced. In another frame, B prime. Really? Hmm. Um, So first off, for Bravo Snipes thing, this is the page that came up when I Googled that. I'm not going to read all this on stream. This is too much. I see it's related to the game of life, which I've heard of. But yeah, I'm sorry. I don't have any existing familiarity with this type of thing. So I'm sorry about that. These the rapidity? As in the velocity between the frames? Oh. Oh, that's the angle of the hyperbolic rotation. Okay. Is rapidity. These equations do seem important. Okay, so CT prime then is I guess BC cosh theta x prime is minus BC sinh theta? Does that match with what you got? Besides the C's, which is fine. Chapter... Oh no, the C equals 1 units. Let's get rid of the C's. The book kind of annoyingly switches back and forth between C equals 1 and C not equals 1. Okay, so over in this frame, these are the components of B, I guess. The xt frame, the a vector points left. I think so, Fembox. I initially drew it as pointing left, and then I erased it because I realized it's not relevant. But I think so. If you contract with A, you get the result. As in, like, we need gammas? I know of the JE exam. I can't solve questions from it. Wait, no. I don't know what the Minkowski product is. I've heard. I know the Minkowski metric is something involving this. Oh, A dot B. Oh. I see what. Okay, thank you. That's what I needed to hear. Um. So I assume like Minkowski product is a way to avoid saying dot when dot. It's not the same dot product as with regular vectors. So we do the negative of the time components. Oh my god, it just pops right out. Huh. All right, Hamiltonian dynamics, thank you. I was going to go on some crazy tangent about trying to do geometry with this metric. And I'm sure I was going to get very lost very quickly. I never thought that I would never have thought of this approach. Shane! Thank you so much for the raid. Holy crap. Welcome in, everyone. I'm Don. I do math help streams. I do game streams. We were just talking about general relativity because I've been learning that. Welcome in, Noger, Big Tuna, Neil, Matt, Shane. I hope your stream was good. If you want to just raid and run and relax a bit, please do. Anyways, here on my end, check out Shane. He's an awesome dude. Streams about history, sociology, and just the world in general. It's a really awesome stream. Super knowledgeable dude. And Noger, I've watched your stream a bit. I've only lurked on you, but Noger also does philosophy streams where he reads through philosophy papers. And for what I've seen, it's a pretty cool stream too. Gotta sneak out for just a bit. You'll be back in around a sec. Sounds good, Shane. No worries. Yeah, sure, Big Tuna Neil. I just got through this one that's on the screen. I often exploit the fact that the dot product of two 4 vectors is the Lorentz invariant. Choose a convenient frame. The dot product of two 4 vectors is Lorentz invariant. Really? Why is the dot product of two 4 vectors Lorentz invariant? Maybe what we just did. I'm sure what we just did shows that in a way. I like how the normal dot product is invariant under rotations. Oh, okay. So yeah, the floor vector dot product to be invariant under hyperbolic rotations, I guess. Being able to choose a nice... It's a generalization of the Graham-Schmidt process? What? That's crazy to hear that connection, color cone. Silver pills. Thank you for the follow. Linear algebra all the way down. Apparently it is. Okay, Big Tune Neil. Why would a 100 amp cable split into two 60 amp connectors and not two 50 amps? Uh, Interesting. Why would that happen? Current is additive whether AC or DC, I think. I've studied like electromagnetism in general. I don't know much about actual circuits. I'm trying to think of what I do know. Proof is quite similar, but you have to be careful about isotropic vectors, light-like vectors. Oh, okay. Yeah, that's a really cool connection to hear about. I can kind of imagine it. Um, hmm. I don't know this offhand. I bet that Meriwether Remark is an electrical engineer who streams, and I bet he would know this better than I. We can start to Google some stuff though and see if we can figure it out. Two 60 amp currents weren't in phase. Maybe they could sum to 100. That's what I'm guessing, Fembots. Yeah. Sorry, I should maybe show what I'm looking at. You know, with three-phase power, if you connect in a delta pattern connecting two phases, 208 volts instead of 240 volts. Oh god, I remember learning about three-phase power. It's been a hot minute. It's a curved space-time. You'll not be able to choose a nice frame like that globally. Think of curvature as the obstruction to be able to find a nice frame. Oh, I think the book was like just barely hinting at that. Where I was saying like you can have like locally nice frames if you're super far away from like mass, but that usually you can't really find a nice inertial frame. 120 volts, okay. This explained. Sorry, I'm not good with JE Advanced. I should just do a pin on the YouTube because that's a very common thing for people on YouTube to ask about. I just learned that you can pin stuff on YouTube, and maybe that would help because I've tried many times to work on those questions, and they're just a little too weird for me. Yeah, so like if like sine and cosine are out of phase by 90 degrees. And so it could be that same thing as what you put there before Tuna or Neil. But like I have a difficulty figuring out what the exact like how getting them out of phase works. Because by that logic, can you also have them both be 100 amps if they're, well, maybe you can't. I don't know. This is for 240 volts. Maybe, what is just sine plus cosine? Like, what is the maximum this ever gets? Root 2. What is 100 divided by root 2, I guess? 70? Set the sign off by 60 degrees to equal 180. Oh, well, okay, so pi over 3 is a 60-degree angle. But sine and cosine are 90 degrees out of phase. So these would be 150 degrees out of phase. Christian from Survivor, is he the host? Wait. Christian Survivor show. Christian Hubicki? I can kind of see it. I don't know if it's spitting image, but we do definitely have some similarities. What season was he on? David versus Goliath. I haven't heard of that one. I watched this a lot as a kid. Hey, creative and unique username. 37th season. What year? Hey, Iriswa? Sorry, I'm probably saying that wrong. 2018. Okay, that's a recent season. Anyway. Graded for short. Okay. Your final statistics assignment all day. Can't wait to have it done. Nice. Nearly there. Yeah, links are turned on. You can just put it there in chat. Wait, does he stream Federico? Or like were you streaming Survivor? Um, it's a bank holiday weekend here, so it'll be done by the end of Monday. Back to Mechanicsburg, so over the last exam. Nice. What type of stats? Are you doing like calculus-based stats, or is it just like not calculus, I guess? Oh wow, Fembox. So we have two 60-degree AC currents that sum to one 100 amp AC current. If you can get the phase shift right. I mean, it's, slightly off, but like, what's 5.1 radians? Yeah, that should be in radians. $292? That's basically 60 degrees, right? Or no, it's 120 degrees. Oh, wait. And that's 120 degrees. No. Really? $1.1 or 1.2. Okay. 60 degrees. Nearly. Interesting. So I assume what's happening there is that they're finding a way to offset the phase. Man, I bet there's something really cool here that I just don't have the background to be able to explain. But it does seem like you can express a single wave with amplitude 100 as the sum of two waves with amplitude 60. Not hyperspace, applied statistical modeling. Ooh. We want to teach teenagers as well about the knowledge you need. Fair. That sounds like a cool class. I'll probably enjoy it. How can we think about this? Like, can we actually solve for A? If we were so inclined. It might be kind of difficult. Uh, I think what this is saying is that not necessarily. Uh, so okay, if you're gonna actually plug something in, I'm not an electrical engineer. I don't want to be the reason that you get shocked or that you break some electronic thing. But if whatever splitter is offsetting one of the phases for the signal, then you should never exceed 100 amp total demand, is what it seems like. Do engineering. I mean, I think it's pretty interesting. I just wish I knew the answer. Um, I just don't want to. I don't want to be responsible for like someone getting hurt and or like breaking something. It seems like it's possible though. Like I feel like you could have theoretically even two 100 amp sources if they're exactly out of phase. Maybe I would hope that's right. But you work with the site's power to understand the reasons behind it. Oh, okay, okay. Um, hey IVK. I mean, I guess it's just about like making sure their peaks don't happen at the same time. It's like the bad thing that you would want to avoid is these two 60s happening at the same time. Because then you're drawing or you're putting out. I don't know if you're trying to draw 120, if you're putting out 120. I guess you're putting out 120 potentially. If they're in phase, then you potentially have an issue where you're putting 120 amps through a 100 amp cable. But if they're slightly out of phase, I guess it would be okay, it seems like. Because the actual 120 peak never actually happens. But I feel like this is a very surface level answer, and I wish I could give a better one. When my heart reads in the hospital for seeing the clown come into the room. Oh, but wait, I don't know which wave you were talking about, but yeah, I'm not a big fan of clowns. To BG Coast? Well, I don't know what that is. So yeah, Neil, I wish I could give you a better answer. I think that's kind of the best that I can quickly come up with. That as long as things are out of phase, that you can be okay. Chief Tattoo Officer, yeah. It's there on screen, or I can even copy paste it back in here. That was the original question. And I've given like a half-assed answer, I think. That might be the best that I can do, though. What's happening here? Oh, is BG cosine inverse cosine in Dutch? Like arc cosine? That's kind of funny. Okay, yeah. I can. Why is this stupid? Uh, Your chalkboard be like. Why is the scale of that so weird? This scale looks perfectly fine. Oh, wait, is there a way to mess with the scaling in Desmos? Is that what you're doing, Fembox? Oh. No, no, no. Spam away. Hey, Jasu. Hey, Papadoria. Yeah, sure. Hit me with it. So your checkerboard be like. These the connections themselves are rated for ranges. My assumption here is splitting 100 amps into 260 amp connectors. That device you can plug in is a 60 amp cable plug. I think so, yeah. Chief Tattooed Officer. Formula watt per volt equal amp. Watt is power, volt is potential. Oh my god. The E and M units. I'm trying to remember. P equals IV. Thank you, Fembox. Yeah. That's the formula I needed. Berg cosinus? Oh, okay. Interesting, Lucas. Reactive power? I don't know what reactive power is. If creating phase shift between voltage and current, we do need complex numbers to accurately describe that. Oh, Renga, I haven't seen you around in forever. I hope you're doing well. Translate notes into Dutch? Can I can't. I can put it into Google Translate. Been busy? Nice, nice. But yeah, so I bet like Merryweather could do a better job of answering this, but it seems like you can time it right so that you never actually exceed 100 amp of demand with your AC currents. Um, but yeah, I have a hard time saying much more than that. It's so cool when I use Desmos, is it? So high tech. I know. I'm really living in the year 2025. But yeah, Neil, if you want to say anything more, I guess I'll try my best with it. Um, but otherwise, I might look at Papadoria's question. Oh yeah, Papadoria. I'm sorry. I turned slow mode on for YouTube because YouTube was really hectic on Thursday, and it was just kind of out of control. So I felt like I had to. Sorry about that. Hey, Xerxes. Or Xerxes, I guess. If you have a simpler question, please ask it. There's no problem that's too easy. There's many problems that are too hard, but there is no problem that's too easy. I'd much rather work on an easier question, to be honest. No worries, Neil. Thank you for trying with me. The maximum of cosine of A. Uh, oh my god. Yeah, you can put it in my Discord. Direction cosines? Oh no, I remember someone asked about that and I was really confused by them. Oh wait, I thought you meant like translate math notes into Dutch. You just mean the word notes translated into Dutch. Okay, that is kind of funny. I'll give it to you, Lucas. That's funny. No titties. Yeah. Fish. Okay, I'll play as what pronounced. That's what I wanted to hear. I was pronounced, so I muted it on stream. So it's not exactly as dirty as it looks, but noticious or something. The maximum cosine is 1, Jasu. Nice. Fish, I hope you've been well. It's not dirty, just sad. Yeah. Life is better with titties. That's a quote right there. Doing good too. I think I told you that I got into grad school, or if not, I got into grad school. So I'm doing a master's in applied math. And for anyone who doesn't know, I'm currently in California and I'm moving up to Washington State for that over the summer. Okay, Xerxes. Thank you for the well wishes. I'm excited and very nervous for it. Oh my god, that's a big image. But yeah, I've been like cramming, trying to study for it beforehand. So Puppeter just kind of dropped his question there and left. So it's not like my first priority to try and solve it. Since Xerxes is here, I think we'll look at Xerxes' question first. The nice part about this, I speak fluent Dutch. You only figured out after someone pointed it out. Yeah. Got a connection to the PNW now? You sure do. And I'm going to be in Seattle, and I looked. It's actually not that far from the PNW map. I was like, oh, hey, I recognize that. I saw like La Push or something. Well, that's why I'm doing the complex analysis reading group color cone. In the first quarter, there's an applied complex analysis class. Oh yeah, I was showing you that. But yeah, I'm also going to want to learn about PDEs. I'll probably do that during the school year, though. Well, I have to see. There's still 2 classes I'm going to have to take. But I still have freedom for one other class, and that other class might be something that I would want to study for. It's always on Tuesdays, Poison Mouse. No, I like PDs from what I've seen of them. I want to know them. J is India's university entrance exam, and over on YouTube, for whatever reason, there's a bunch of people who really badly want to talk and argue about it, and I'm kind of over it. That's why I have that pinned message there in YouTube, Xerxes. The questions, I just genuinely am not good at doing them either. Oh, okay. I thought PED was just a typo. I don't know what an anabolic is, but I assume that's a drug or something. X is on OB. ON. A, okay. OP to PN. It's 3-2. Oh, I do know what PEDs are. Never mind. Sorry, I'm such a nerd that who doesn't care about sports that I forget that PEDs are performance enhancing drugs. Not A. Some constant, I guess X. No, not X. C? Don't mistake me, don't take a research seminar on PDEs as your first graduate course on PDEs. That course was trauma. I bet it will be. In the third quarter, I'm going to have to take a class on PDEs, but I might have to take one involving PDEs before that too. I'm not sure. Think about two fish, yeah. Find AX in terms of A and B. So find AX in terms of A and B. Oh, really, Chief Tattooed Officer? I'm giving this up like on the screen so we can keep on thinking about it. That feels like a Roots of Unity thing or something. Squared. Three-fifths. Ah, no, this is. Three-fifths A plus B and two-fifths A plus B. Oh, sorry, Xerxes, he put something in chat. For OP, put his three-fifths. PN is two-fifths. That seems reasonable. We can take OP equal to three-fifths. OB to KB. KB. I don't know what K is. Parallel to AN but longer. Yeah, OB is definitely parallel to AN because it's a trapezium, I think. That shown us some oral presentation on some recent paper. Showing how bad I am at PD. Oh no! That's like, so you're doing like the cutting edge of PDEs too. Three over two B minus A for AX. Oh my god, 15 bucks. I haven't even like really started on the question. OB is some constant times B. Oh, I see. Okay. So yeah, OB is equal to some constant K times AN. And AN is B. Aha. The medians meet? I have no clue. I don't know what the median of this would be. What the hell? Oh, so you're looking at a triangle there? A triangle somewhere else? I don't know. Yeah, this question is not easy, Xerxes. OPX, APN. We know angle, angle. Do we know anything else? These, angle, angle. We need, like, these sides to be the same. Oh, wait, no. No, yeah, they are similar. Angle, angle, angle. Okay. So yeah, Hamiltonian dynamics, I agree. No, I think they're the same question, Jasu. Angle, angle, angle. um, AOXN. I'm just not even thinking about this for myself. I'm just trying to let you guys solve it for me. That's the mode I'm in right now. I don't know that AOXN is a parallelogram. I don't think that's true. I think this being split up in a ratio is messing that up. I feel like it is. Oops. Use ratios to get OX. That's a thought. Why is there a 2 where? I don't know. Okay, I'm gonna follow Hamiltonian dynamics' train of thought. Triangle APN is similar to OPX. And we know that 3 times OP is 2 times PN. So all the other sides are split up in the same ratio. So that means 3 over 2B times 2 is equal to 3 times OX. Is that how that works? Isn't that just B equals OX? Wait, am I? No, no. I'm sorry. B. I did the 3 over 2 thing twice for some reason. OX equals 3 over 2B. Okay, so we agree there. OX to AN. Yeah. And now we want to... What do we want? So we know 3 over 2B is right here. Can we think about this triangle here? OA plus AX is equal to OX. Really? That can't be true. Isn't this a triangle? As vectors. Oh. Aha. So A plus AX. So AX Okay. Xerxes, you said you have the answer. Is this it? 3/2b minus a? We just ignore this entire side of the trapezium. Feels bad. Surprisingly good or surprisingly bad? So Xerxes, if you want, I can go back and explain what we did here. But is this the right answer? It doesn't. Completely separate. Sorry, Jasu. Oh, I'm sorry if that's what you meant. There's a divider here. I thought you meant, is this figure related to that question? Sorry, I misinterpreted you. Completely separate. Same thing. Okay, so yeah, so we did get the right answer. So the way that we did it was pretty short. And by we, I mean chat, and I didn't help. The first thing to realize is how should I do this? Triangle APN, that triangle there. I already drew it wrong. Is similar to triangle OPX. I'm going to rotate OPX. OX. And we know that we know the ratio for for NP and OP. If NP is 2, OP is 3. And so that means all the other sides are split up in corresponding the same ratio. The thing we really care about is AN is also B. So that's how we know 2 times B, sorry. I messed up these ratios. Three times NP is 2 times OP, right? So 3 times B is 2 times OX. Yeah, and then you can divide the 2 over. I think I'm stating this wrong. These actual amounts are wrong. But it is true that, yeah, the numbers I put there are wrong. 2 OP is 3 PN. Dude, ratios are fucking annoying. They're important, but they're annoying. I'm too OP. I feel like I'm not OP enough right now. But okay, yeah. That means if NP is 2, OP should be 3. That's kind of, I wouldn't even think about that though. That's just kind of confusing. The Point is, OP is on the triangle on the right. Any triangle on the right gets the 2. Any triangle, any side on the left gets the 3. So 3 times B is 2 times OX. That's how I would set up that ratio. And then you just divide, we want OX, so divide the 2 over. And so we know that OX and AN point in the same direction, or OX and B point in the same direction. So we can say that OX is 3 over 2 times B. And now, just by the definition, if we make AX a vector, we can use a definition of a vector addition here, where A plus AX is 3 over 2B from that like tip to tail thing. So yeah, I think that's the quickest way of doing this that I know of. And once you know that vector addition there, you just subtract the A over. And you have your answer. Yeah, no worries. Thank you for the carry on that, chat. Okay, back to Papadori's question then. I want to test out that 120-degree offset. I'm asking ChatGPT to check my work. Like, hell no. That's 0. It's a joke. Oh, okay, okay. You're gonna beg Keo Arts. Then very interesting. Awesome. Well, thank you so much for hanging out for as long as you did. I hope you sleep well. And yeah, it's good to have you around. Claude can do topology and category theory? Wow. Is Desmos not in the UK? All right, see you, Poison Mouse. Thank you for hanging out too. Jess, I'm thinking this is like constrained optimization. Given these constraints, what's the most cosine A can be? Lagrange multipliers? We have 2 constraints. Can we... I don't know Lagrange multipliers work with 2 constraints. Do I know that? I don't know. Do you know what it is here? Oh, fair, fair. Yeah, these are 2 equations. Oh, you thought it was one big equation? No, no, no. Maybe I should do this. Song just ended. That song was Anemoia? Anemia? Is that how anemia spelled? Why is there an O in it? The playlist. So we could really waffle stomp too. Yeah, that's just what I was thinking. Hey, Cook, how was London? Are you still there? Are you back? Uh, is it? Uh, okay, so let's go down the road that Jasu and Chief Tattooed are saying. If A is, I guess, 0, can we find a B and a Y that satisfy the other two things? The waffle stomp is the new dance craze. Um. Oh. Wait. B equals pi over 4. Oh, these are probably Greek letters if that's a Y. 5 pi over 4. Doesn't this just work? What, like an iPhone, it just works? I'm putting this into Wolfram Alpha because I don't trust my brain. No, it doesn't just work. I'm violating the second equation here, right? That is 1. But the sine one is bad. Yeah, that's 0. That's an issue. Ooh, Territar. Um, U equals tan B over 2. V equals tan Y over 2. Um, how do we plug this in? Are we just embracing the inverse trig? Are we dividing or no? Cosine B is 1 minus u squared over 1 plus u squared. Really? I guess you need like a double angle and to draw a triangle? Is that? Territar is cooking. And I assume we get analogous formulas over here. Okay, so what happens here? Um, Does this solve any of our issues with having, or, The sign has to be equal to 1, though. Poison mouse. Yeah, if it was equal to 0, I could think of a couple of... Oops, I just made it equal to 0? There'd be quite a few solutions, I think. Walter, nah. I think same is fine, Cassio. There's no constraints that Papadoria gave us. Venvox wants to assume beta equals gamma? Maybe, I don't know if we can do that well. It might be like beta equals minus gamma or something. I don't know how you're thinking we should solve the system of equations, Territor. This seems difficult. Hmm. And so this is Papadoria, who's known to give very tricky questions. I'm trying to think of some kind of trick or something. Oh, Zone Ranger? I don't know why I'm using Wolfram Alpha for this. I should just be able to do this in my head, but that checks out for sine. Okay, Zone Ranger found an answer. That's simple enough that we should be able to guess and check that, I feel like. I wonder if there's a better way. What's happening here? I was taking advantage of like the symmetry of the unit circle. Okay, so cosine of 0 is 1. Cosine of pi over 6 is root 3 over 2. Cosine 5 pi over 6. So minus root 3 over 2. Sine of 0 is 0. Sine of b is 1/2. Oh. Huh. I feel like I should have tried harder with guessing and checking. This doesn't seem that crazy to just figure out. I assume that's what Zone Ranger did rather than trying to do like an algebraic solution. Cosine squared A is 1 minus cosine B minus cosine C squared. I was wondering about squaring as well. The Lagrange multipliers will be possible? Okay. Yeah, I got tripped up by having two constraints for Lagrange multipliers. I'm not very experienced with them. Okay, you know what, Jasu? With your idea, you would get two equations and two unknowns? It'd be really annoying to solve it, right? Send them some sardines? Shouldn't you be in bed, Poison Mouse? I think... I don't know why sardines. Max cosine 1. Yeah, I guess it still is 1. Stream's gonna be addicted, fair enough. Let me add Papadoria in chat. He's not here, but just to make it easier for him in the YouTube VOD. Nah, it's fine. He'll see it, and I'll put timestamps on it. Yeah, that just kind of works. I mean, you can simplify it. I think it's gonna be really painful though. Maybe you get some cancellations. Okay, fine. I want to see it now. Um, Cytos, we can take a look at that. I've been writing off your questions too much, so I just want to see how this looks, and then I'll give your thing a try. Yeah, we're gonna get a lot of like Pythagorean identities between these two things. Um, I I want to do this mentally. Ahmed, yeah? Why would I lie about that? It's these cross terms that are annoying. You can probably collapse them into one thing. I think it's what you would get. I did a lot. I did this entire simplification mentally, but I think it's what you would get. Oh wait, I have more than two twos. I think it's a 4. Don't type your login credentials anywhere, Ahmed. I don't know. I don't want to deal with this anymore. Let's look at Cytos's question. Uh, Pretty run-of-the-mill YouTube stuff. I'm ready to delete messages if I have to. Imagine trying to solve math problems while you are trying to keep an eye on that. Hey, Malay fan? I'm saying that right? Kind of holds to claim any understanding. Can you set sum of cosine equal to sum of sine? Oh, thank you, Territar. Yeah. Um, so the sum of cosine equal to sum of sine, these are sine theta form. Oh, you could definitely set them equal to each other. R sine theta form, I'm not sure what that would mean here, though. I don't think I know what where you're going next with that, Malay. Oh, but yeah, I just remember Territar's a mod over in the YouTube chat. Um, hire some mods. Maybe at some point in the future. Really, for Twitch, it needs almost no moderation. YouTube needs a bunch, but I feel like Twitch people are pretty like well behaved. Can you spoil the answer, Renga? Let me think about it just for like a couple of minutes. Oh, did I? You're right. It's more like that. Central, hello. Yeah, Central is a model citizen for Twitch chatters. Never says things that are like borderline. 3 variables in sine. Change it as you want. Yeah, I'm sorry. I'm not sure that I'm following. But it's also hard for me to follow trains of thought like that sometimes. So it's not necessarily you. Ahmed, yes. Please don't type your username or password in any chat. Not my chat or anyone else's chat. It's not homework help like that. I don't do your homework for you. Um, why from zero to infinity? Why not? I don't know. How is this series behaving? Um, it's oh, ugh. Sorry, as a sequence rather. It's doing uh uh it's something like that as a sequence approaching 1. Oh, and yeah, n equals 0 isn't. I think we need to start from n equals 1. Even 1 doesn't look good. It doesn't look good. Let's put on some weight. 0 doesn't work, though. Slidos. Are we dividing by 0? He has Subas? The limit they canceled a 1? What? You're telling me when x goes to 0 from the right of ln 1 plus minus 1 to the x over x plus the limit as x goes to 1 from the left. I assume the direction is important. I don't know. That limit is 1, apparently? Is 0. I mean, I don't think you're allowed to use limits without, or like as you've written it, you can't use a limit like that. If it's going to be 0 anyway, let's just start it from 2. I think that there's something that why would you allow that? Even discussion, even this is true. I don't know if it is, but so the limit definition of Euler's number, it is kind of that vibe, but it's a little bit different to my eyes. Subas's asking, what is a function? I'll answer that quickly. A function, it just, you give it a number as an input, it assigns another number as an output. And the constraint for a function is functions take a number as input and output another number. The one rule is that one input cannot have multiple outputs. That's the big thing, and that's what's often showed as a vertical line test, where if this is our function here, you can draw a vertical line anywhere and it only hits the function once. So this is a function. Whereas if you have a function like that, I can draw a vertical line here and it hits the function twice. So that's not a function. It'd be called a relation. All valid inputs have at most one output. Oh, that's a little, that is better. Yeah, that's more accurate. Touch, yeah, you can ask a question. Mert is saying it's kind of a telescopic series. Oh, there's oh, interesting. Um Yeah, these first two terms, you can use a log identity to make them 1, and that becomes 0. So is this entire thing going to zero out? Yeah, I think it just zeroes out. Funny. S2k and S2k plus 1 can be still seen as a sequence. Interesting. Where are these questions? The three places where I get questions from are Twitch chat, YouTube chat, and my Discord server. It's not really just one place. I can scroll up and down in this document. But there isn't really a central location, unfortunately. um, okay, so there's been some questions over in the YouTube chat. Sudas asks, what is a determinant? Can you tell me what context are you working in? Because that's a little bit of like a big question, I guess. A determinant is something that you do to a matrix. It's like a number that tells you some information about a matrix, basically. You so Taksh, why is there a dot dot dot? Is there a part of the question that's missing? Yeah, three blue, one brown does have a linear algebra series. That's a discriminant, right, Jasu? Or well, actually, no. I mean, I guess we're talking about whatever the hell it's called, positive definite. It goes on forever. Oh, I see what you mean. Uh, it's a nested root. Oh, Territar, you sly devil. Yeah, just make it recursive. Um, yeah, you could square it too. Um, let's actually square it. Now let's find dy. Now let's take a d by dx. Yeah, I think that's just what you do right there. Thank you for that, Tartar. Subastas, you got to give me a little more context to go off here. You're asking me a lot of very different questions, or you're just kind of putting different math things in chat, and I don't know what you want to know about them. Or like, I'm a little confused by where the questions are coming from here because they're very different things, and you're just kind of giving me like little things. You never liked that trick? I don't mind it. Made this problem a hell of a lot easier. The circumcision of a circle? You mean the circumference? I think it's just a definition thing. I don't know. It's playing with the DFC? Really? I didn't know that. Can solve for the function in finite terms by solving the quadratic instead of leaving the infinite nest in your answer. Can you? Um. Oh, wait, I see what you mean. From here, or whatever. Or I guess like there. You're right, it is minus y. Thank you. Huh. That's kind of crazy. This, like, this and this are equal. It seems. Completing the square? I'd never want to complete the square if I don't have to. Oh, true. There is a weird thing. Do we know? I guess it has to be positive, right? That's how we know to take the positive. I mean, completing the square is a really helpful thing. It's just really annoying. Equate those two and find x. We might wrap up for the day with this last one here. ln of I times e squared? Well, this is just 2. ln of I guess we need to put that in I pi over 2, right? Yeah. So 2 plus I pi over 2, I think. Assuming the principal value of the log. I think you do a capital L if you're doing that. Or something. I don't know. I don't remember. I can say how that works. Awesome. Okay. That might be it for my voice for the day. It's got to be it for me, I think. But look at all this math that we did. Yeah, we're gonna cut things off there. So people on YouTube, I'm just gonna cut the stream off here. On Twitch, we'll look for a raid. That is here on YouTube. Thanks for being here. Logarithmic, thank you for the follow. That's an awesome name, like Rhythm. I love that name. But yeah, goodbye YouTube. Is Ivan on?